I did my project on the flammability of different types of wood, and my name is Haley Labdon. So the flammability of wood. Depending on the species of wood, the classification, and the current condition of the wood, it can burn in a variety of different ways. Soft and hardwoods have specific characteristics, making it both good and bad for burning in various occasions. When wood is wet or drenched in sap or other tree products, the burn rate and density can be altered. For instance, when it's wet, it's usually known to be a little bit slower compared to when it's drenched in sap, which is extremely flammable. It should burn faster. So the thought that comes to mind when you think of this is, why do some types of wood burn faster or slower than others? Bamboo and oak are both hardwoods, known to last longer and produce a more consistent flame. Cedar, on the other hand, is softwood, and by trying all three species in a variety of situations, the species as well as the circumstances will test flammability. With 3 different species, we can determine which species alone burns best and which burns fastest in water and sap as well. Water is generally known to slow down and harshly affect flammability rates of most wood, as previously stated, whereas sap is known to help ignite flames since it's highly flammable. The unaffected piece tests species alone without added products, and with all 3 scenarios, the flammability will be timed and charted and later compared. So how could we use this research? In the occurrence of house fires, depending on the material of the building, firefighters may be able to determine what best method of extinguishing to use. Knowing how long it takes different types of wood to burn can help reduce out-of-control flames or burning under harsh circumstances. And this is known, but some woods produce aroma, and for specific fuel, that aroma can become harmful under specific conditions. Bonfires are a common event that can be improved by exact preparation for the fire, including planning the species based off of how long you want the fire to last. Some questions that arose were, does water or sap have a more negative effect on flammability? And would certain species benefit from wood or sap while others are negatively affected? And how big of an effect does the soft or hardwood classification have on the flammability? When different species of wood are burnt under different conditions, they will burn at different rates and have different outcomes. Softwoods are more flammable than hardwoods. Although this is not always the case, more times than not, softwoods tend to be more flammable because of the difference in density between the two. Water is known to negatively impact the burning of wood, while sap is extremely flammable and is sometimes used as a fire starter. The materials I used were a fire extinguisher, 3 cuts of oak, cedar, and bamboo, so 9 cuts in total, a lighter, pine sap, and a small paintbrush. My independent variables were the wood that burns the fastest, whereas my dependent was the kind of wood that the experiment is taking place on. The constant variables were the location, temperature, position of slabs, time, size of wood, and amount of flame set onto the piece of wood. The experiment will be controlled by closely monitoring the location, the temperature, the time, the position of slabs, the size of wood, and the amount of flame set to wood. The setup and design was set up on a wide stove, so all slabs got equal and consistent flame throughout the entire process. Water bins were on each side of the burning wood to ensure safety, and pieces of wood applied onto burner were using long metal tongs. This was designed so each wood slab is equally lit on fire and that the fire is consistent until the flame goes out of the wood. The procedure was quite simple. I created a chart before making it happen. I prepared the surroundings and I burnt the 9 pieces of affected and unaffected wood. I charted the data and took notes on observations. After collecting the data from the experiment, the chart is filled up and the species are compared with each other. So as shown, cedar was the overall unaffected fastest burner. This was anticipated because it is the softwood of the bunch, but what wasn't anticipated is that it was the slowest when it was wet, compared to bamboo, which was the slowest unaffected and the fastest wet. And they all had very similar times with sap, although cedar was still the fastest. Here's a chart of my data, just to lay it out. As you can see, I have all 3 species, as well as the condition it was burned under, in order. So overall, the hypothesis and questions were answered and is supported by the data collected in the experiment. Softwoods are more flammable than hardwoods, which makes great sense as to why cedar was the overall fastest burner. Based on the reasoning behind the effects sap and water, having the sap-coated slabs average to be quickest was expected. So with the collected data, experiments could be conducted to further test how water affects wood by soaking the slabs for longer and shorter amounts of time. Trying the same experiment with different species would help to determine the overall effect of soft or hardwood classifications to an even further extent. In the fields of carpentry, firewood services, and firefighting careers, knowledge of the best woods for certain climates and circumstances could prevent house fires and potential dangers in the future.